Welcome to another episode of How It Works with Holger. Today, I don't want to make promises. Today, I want to talk about promises with Delphi. And if you have heard of promises before, it's very likely if you are a developer that you have, but not associated with Delphi. And that is really something that we have to thank TMS for, because they will bring promises for cross-platform development in Delphi. As a Delphi developer, promises were something completely unknown to me a couple of years ago. So, just as an introduction, the formal definition for everybody watching this. Promises in programming, of course, represent eventual completion or failure of an asynchronous operation. And that allows you to handle the result when it becomes available rather than immediately. And that is the important thing to remember. You will get some kind of feedback from a promise, and that is the important thing to remember when it becomes available. So if you issue a request for something, you get a promise. And that promise is, as soon as it becomes available, either completion or failure, you will be able to continue in your code. The informal definition, it might help you at first. Think of a promise like a pizza delivery guy. You order something, meaning you make a request. The guy is most likely going to say, okay, coming right up. So that person returns a promise. And then either the goods are going to be delivered, meaning you resolve the promise, or the person is going to give you a call, there has been an accident, and you're not going to get your pizza. So the promise is rejected. And those are the two formal terms, actually, resolving a promise and rejecting a promise. The use case you will see a million times all over the internet is requesting data from the internet using promises. And that's exactly why would we change this, right? What I'm going to show you today. So first, you start by issuing a request to a server. And then you would wait for the server response, and if successful, you would process the server response. And if there is some kind of failure, you would show the error. The difficulty is, of course, if this were an asynchronous request, waiting for the server response is not something that we can do in Delphi code line by line. Meaning, if you issue the request, the next line would be executed right away, and you would then need some kind of mechanism to either process, hey, this was successful, or hey, there was a failure. And in Delphi, that is kind of easy, because if you issue a request using one of the request components that are available for HTTP, for example, you can define events that are going to be called if there was success or if there was a failure. That's all nice for one request. But what if you have the following situation? If you chain multiple requests. The example that I'm going to show is exactly something like this. We're going to ask, tell me all the neighboring countries of Germany. And then the API is going to give us a list of countries. However, it's not going to name the country. Instead, it is going to give us the ID of a country. So we need several additional tasks or requests in order to find out what these countries are actually called. So in code, this will mean we would have to issue a request, we would get a list of the bordering countries, and then for each of those country identifiers, we will have to launch more requests. And now consider doing that using events. So you would need some kind of identifier for the request, and it is very, very complicated. And promises give you the way to simply say, request this, then request this, and then request that. And the best thing is, if there is an error in any of the requests, you can catch them all. And that's exactly the terminology the framework from TMS is also using. They use then to process successful promises, and they use catch to catch the reason why something failed. All this, what I've just shown you, is possible with TMS FNC Core. And TMS has a great blog post that I will link in the description of this video. In this video, I will explain the demo step by step in greater detail than it is given in the blog post. You can enter the name of a country and you can click Get Bordering Countries, and you get the list with the name of each country. At the core, TMS uses a REST API that is freely available. We can have a quick look at this API. First of all the requests are being issued to the endpoint restcountries.com. That's the name of the API. So each request goes to https restcountries.com/version 3.1, and then you need to select the operation that you want to execute. In this case, we want to search for a country, for example. So I add /name and then the name of the country, for example, Germany. And then I send a GET request to the web API, and I get the reply, as it's seen here. And the one thing that is of interest of us is right at the bottom. See, you get a lot of information about the country, but we just are interested in the borders. And the problem is that we're not getting the name of the country. Instead, we're getting the short code of that country. We as humans know that this is Austria, Belgium, and so on. But it would be great if we could ask the web API what these countries really are. And this is what the demo will do. It will use these short versions and will then get more information for us with multiple requests. So for each of these codes, we will issue additional requests to the web API in order to get the name of the country. The amazing thing is that in code, we can write it like this. We can say, get me the name of the country for this code, and then, if it is successful, process the result. That's the key message of this video. And now I'll guide you step by step through the demo how you can build this yourself. Because I have to say, the code is a little bit challenging at first because you will have to use interfaces and, to be more precise, generic interfaces. But the payoff is immense that you will have. It is an amazing feature that you can introduce in all your web API calls. And depending on the feedback that TMS will get to this feature, they promised, no pun intended, that they will add this to their cloud frameworks, for example, so that you can write code line by line instead of using events to read information from cloud services that are included in their TMS FNC cloud package, for example. In order to understand this, we have to start somewhere, right? So I'll do what every Delphi developer does. We click on the button and we see what is happening. So we start with get bordering countries, and that gets as an input the text of the edit control. And here is also the nitty-gritty detail how you can use promises to wait for either failure or success. And I'm a pessimist, that's why I list failure first. In code, you usually list the success case first, meaning the promise resolves, and then the failure. And this is what you can see here, not focusing too much on the syntax at first because it will get clear if you use it. You call your function like this, execute REST country request, which will return a promise, meaning the execute REST country request gets the endpoint here in this case and what the user entered. And if we look at this function right here, we see that we create a new function and then we include the code that is being executed as an anonymous procedure. And the procedure that we have to define inside of a promise either resolves or rejects. And that is all that is in there. And of course, there is a little bit more, basically that the success case returns a string and the failure returns an exception. And that makes sense, doesn't it? Because if our web request looking up a country is successful, we will get back a string with the reply from the web service. And if we have failure, we will end up with an exception. And that's what we can code here. So we set up the request using the FNC cloud-based request. There's blog posts available. Once again, you will find it in the description of this video how you can use the FNC cloud-based request to request information from the internet. And we use the service that I just mentioned. In addition, we add the path, which is names in this case, because that's how we call this method. And then we add the name of the country. Furthermore, we want the string as a result type, so we can pass it back to the caller if our promise resolves. And that's the last thing we have to do. So we can execute the request. And the cool thing here is that the execution is asynchronous, meaning this code here is being executed as soon as the request has been processed, either successfully or there was some sort of failure. However, the key is that this is called automatically from execute request sometime in the future, meaning that this line is being executed and then your code rolls on. Especially for the caller here, usually that would mean that this would be called right away, and you would right away execute this code, but not so with promises. With promises, you have the chance to say, if this is successful, then do this. And if there is some sort of failure, you have to scroll down here, then catch the error. That's the key point about promises. And if we go back to the request itself, you can see that we do just that. If the request is successful, then we resolve the promise. And this aResolve is this parameter here inside of the promise. And if it is a failure, then we will reject it. And the cool thing is that what TMS is planning in the future is that they provide this for you, and you have the chance to concentrate just writing this. So you can focus on implementing the case if a request to a cloud service is successful or if there is a failure. One tiny little thing I have to focus on is this main here. That means that you need to execute your code on the main thread because you have some sort of user interface interaction. So even that is implemented in that framework, because here we change the lines, or we add the lines to the memo field. And that means that the user interface would be used in a background thread if we don't force the main thread. And even that is possible, chaining these commands together. So instead of spreading your code among events or other parts of your application, everything runs top to bottom, and you have the positive case if everything is successful, and you can say what happens if something goes wrong. And I won't go into the nitty-gritty details of this example where we parse the JSON result, for example. That is something you can look at yourself and you will understand it right away. The focus here is that you create a promise, which is created using this method, because this method here returns the I promise, and it returns the actual, if successful, it will return a string, and if not successful, it will return an exception. So that is the key thing to remember here, that you can model both success and failure, and then can concentrate on writing your code one step to another. You don't have to focus on the asynchronicity. Your code executes from top to bottom as if it were non-asynchronous code, and that makes promises so powerful. Finally, we have, as I said, not only one promise when we request the names of the countries based on their short name. And this is something you can do as well. So for each bordering country here, we create one promise. And then we can say we have the result when all promises are successful, meaning if we have all the names of the bordering countries. So this is a very, very powerful statement here that will wait until all the promises are successful. And if one of them is not successful, we will once again be able to get the error or catch the error using show message and show it on screen. And again, it has to be executed on the main thread because show message uses the user interface. Let me finish with this. I know that the source code for this is not trivial at first, but TMS gives us a great example which you can study, and then you can step by step try to apply this to your own use cases. Please have a look at the blog post that TMS posted a couple of days ago, how you can find more documentation and more examples in addition to this, and I hope you're just as excited about promises in Delphi, because TMS is truly driving innovation in Delphi forward here and is adding things to the language that are not possible with the base product of the language. And let me emphasize this one more time. This is available in the FNC Core package, which is available for cross-platform development, meaning you can use this for Windows, for Linux, and for mobile. And you're not limited just to using it in Windows with the VCL. Thank you so much for your interest in this video, and take care.